Today we're going to talk about some rules that log expressions have. This is on page 3 of your notes. So get your notes out. Chapter 8, page 3. It looks like this. There were rules when we studied exponential functions back in chapter 7. There was a product rule for exponents. There was a quotient rule. There was a power rule. And since a logarithm is just an exponent, logs have rules or properties just like exponents do. And we're going to be looking at some of these. Now, the first thing you see here is a log expression, and I just want to let you know what I call these two parts of the log expression. This little subscript here, b, is the base. I think I mentioned that in the last video and we talked about it in class. This is the base. And then what comes after the word log? Like I would say, this is the log of AB with a base b. This is called the argument. No arguments, please. No, this a times b is the argument of this log. And if you have two things that are multiplied, if you have factors, it doesn't have to be two, it can be more than two factors. As an argument of a log, you can do something called expand this out. And this expands to what I'm going to write here. What you're going to expand this out is the log of a times b is equal to the log of a plus the log of b. And the base here stays the same as that little b. It doesn't matter what it is. So these two are factors, but this log, this is called a function. A log is a function, and you can't distribute logs into, like this is not the log of a times the log of b. Even though these two are multiplied by each other, this is the log of the first factor plus the log of the second factor. So one log expands or splits into two logs. This over here, it looks like the word in, but this is actually an L. This is ln, and ln stands for natural log. A natural log is just a log with a base of e. E is that number we learned in the last chapter, that 2.7 number. So anytime you see an ln, you can always rewrite this as log base e of whatever. So a natural log, just like a regular log with another base, expands into the ln of a plus the ln of b. There's a quotient rule. When two things are divided by each other, it's almost like the product rule, but instead of a plus, you put a minus. So the log of a divided by b is the log of a minus the log of b. And then as an afterthought, I usually just put the little base b as a subscript way down there. Make sure the subscript goes way down. And the same thing when you have a log base e of a over b. This is a log base e of a minus a log base e of b. So if you have a quotient here, you subtract those. It's just like the exponents. Now a power rule is a little bit different. Whenever you have the argument raised to some power, what I'd like you to do is I'd like you to circle that exponent. In this case, it's an x. So circle that x, draw an arrow out into the front, and then drop that x out in front, and then that x goes away. So the power rule of log says if your argument has an exponent on it, you can pull it out front and make it x times log of a, the little base b. And you don't have to surround these arguments with parentheses if you don't want to. I guess I'm being a little inconsistent here. So you can put the parentheses, you don't have to. And then in the second one, you bring the x out in front of the natural log. So this is x times the natural log of a. And that's all there is to it. There are only 3 rules that you have to remember for logs. And they're used in all sorts of ways. Now there's a little note here. If your argument is a sum, if there's a plus or a minus inside these parentheses as the argument, there is no rule for that. You cannot expand these. So put that as your little note. cannot expand sums or a difference in two arguments. Whenever we have it says these rules can be combined into a single expression, which means we work backwards. If we're given this, we can work backwards into this, and we'll do some examples of that. And when they're combined into a single expression, it's called condense. And the opposite of expand is condense when you're talking about logs. Whenever you see a radical written in the argument of a log, you should always rewrite it having a fractional exponent. You can remember that the square root of x, there's a little invisible 2 here. The square root of x is the same thing as x to the 1/2 power. That's just from the last chapter. So if we ever see a square root or a cubed root or any radical in a log expression, we're going to write it with an exponent. So here's how it goes. Number 1, I'm going to do my work under here. We have 3 factors. We have a log base 4 of 4 times x times y, so we can expand that into the log base 4 of 4 plus the log base 4 of x plus the log base 4 of y. And we can simplify that down one more step, because if you remember this base, this means the exponent on the base 4. What is the exponent on a 4? That would equal 4? Well, the exponent on a 4 that it would equal 4 would be 1. So log base 4 of 4 is just equal to the number 1, and this is 1 plus log base 4 of x plus log base 4 of y. So there's your final answer. 1 plus log base 4 of x plus log base 4 of y. So you can see that this one log expression expands, so we just expanded it into 3 different terms. One term goes to 3 when we expand. The next example, number 2, now we have an exponent. So I'd like you to circle that exponent, drop the 3 down in front. This is a natural log, which is just a log with a base e. So this is 3 times the natural log of x, and that's the end of that problem. Number 3, we have a quotient rule here. So I'm going to do a little bit of work underneath and write the final answer up on the top. This is the log base 2 of 16 minus the log base 2 of a, because this is the quotient rule. One log breaks into 2 logs. And we can simplify this part right here, because if we asked ourselves 2 to the what power is equal to 16, that's really what this is asking. So 2 to the what power is equal to 16? Well, 2 to the 4 is equal to 16. So the log goes away. This is not the log of 4. It's just the number 4 minus log base 2 of a, and that's the final answer. 4 minus log base 2 of little a. The next example, we have a radical here. So we're going to rewrite that radical as x to the 1/2 power. So this is the natural log of a squared times x to the 1/2 power. We have 2 rules we're going to use. We're going to use the rule with the exponents in it, which is the power rule, and we're going to use the product rule. So what this does is this splits apart into the natural log of a squared plus the natural log of x to the 1/2. The product split into 2 logs with a plus sign in between. And then we're going to circle this exponent and drop it down front, circle this exponent and drop it down front. And our final answer will be 2 times the natural log of a plus 1/2 times the natural log of x. And that's it. We have 2 rules in one expression. In this next expression, we have all 3 rules that we're going to be using. So what we're going to do is we're going to rewrite this z. I think I'll just cross them out and write it as z to the 1/2 power. And what we do first is we take care of the quotient rule first. So the quotient rule says that this log breaks into the log of the numerator minus the log of the denominator. So this becomes log base 6 of the numerator, xy squared, minus the log base 6 of the denominator, which is z to the 1/2 power. So there's your first step, just using that quotient rule to split it apart into 2 logs. The next step we're going to take is we're going to use that product rule because we have a product here, x times y squared. And this one log breaks into two logs. The first one will be the log base 6 of x, and the second one, because this is a product, we're going to add to that the log base 6 of y squared. And then at the end, we're going to tack along the log base 6 of z to the 1/2. Now what happens is we have two of these expressions having exponents on them. So we're going to just pull the 2 down in front of this one log. We're going to bring the 1/2 down in front of that one log, and then we'll be done with that problem. This turns out to be the log base 6 of x plus 2 times the log base 6 of y minus 1/2 log base 6 of z. So one log split into 3 logs in this case. Number 6, we have a natural log. Again, we're going to use the product rule, the quotient rule, and the power rule, all 3 in this one. So first, use the quotient rule. This splits out into the natural log of x squared times y minus the natural log of z to the 4th. Make sure you write 2 logs. The next thing we're going to use is the product rule. So this is the natural log of x squared plus the natural log of y, and then subtract out the natural log of z to the 4th. And then the last step we're going to take is we're going to bring that 2 out in front. We're going to bring that 4 out in front. And our final answer is 2 times the natural log of x plus the natural log of y minus 4 times the natural log of z. You can put parentheses around these arguments if you want. Example number 7. Now we have, again, a quotient rule that we're going to handle first, which is the log base 5 of 25 minus the log base 5 of xy squared. Quotient rule comes first. The log base 5 of 25 can be simplified because there is a power of 5 that's equal to 25, 5 to the 2. So this log base 5, 25 goes right away and it just becomes the number 2. Minus, now we need parentheses because we have a subtract or an addition here. We're going to do the log base 5 of x plus the log base 5 of y squared because this is a product, xy squared. But we need parentheses because this parentheses will distribute. The last thing we're going to do is we're going to bring this 2 down in front of that word log. And in my answer line, I'm just going to distribute this negative into that and that term. So the final answer will be 2 minus log base 5 of x minus distributing 2 times the log base 5 of y. And that's the end of that problem. On number 8, this e to the square root of e is going to become e to the 1/2 power. So this is a quotient rule. This says we're going to do the natural log of 1 minus the natural log of e to the 1/2 power. Quotient rule. That divided by that splits it into 2 logs. Well, ln's are just log base e. A lot of times I rewrite it as log base e. I said that before. Log base e of e to the 1/2. So this 1/2 drops down in front. And now we can ask ourselves, e to the what power is equal to 1? Well, it doesn't matter what the base is. Any base that you give me, anything to the 0 power is equal to 1. So this could have said log base 7 of 1, log base 10 of 1. No matter what, the log base anything of 1 is equal to 0, so I'm going to replace that with a 0, minus 1/2 log base e of e. Well, here we go again, because e to the what power is equal to e? Well, e to the 1 equals e, so this log base e of e can just be taken out of there, and we can call it 1. So this becomes 0 minus 1/2 times 1. It's just a substitution that we made, and the answer is negative 1/2. And that's the end of that problem. So anytime you can simplify a log expression, like if you can say the base to what power is equal to that argument, then you can substitute. If you can do that math easily, then just substitute it. So that's called expanding. Now going in the opposite direction is called condensing. So when we condense these expressions, if I see two log expressions with a plus sign in between, going the other way, condensing means we're going to bring this down into one log expression. So two logs become one log. This is a log, the base is 4, and we're going to multiply these two arguments because of the plus sign. So this is log base 4 of 4x times x. And 4x times x is 4x squared, so this would be log base 4 of 4x squared, and that's the end of that. Condensing. Condense means make one log out of two or more logs. Number 2. Oops, hopefully you saw everything here. Maybe I'll zoom in a little bit. Maybe I'll see if I can focus this a little bit better. Whenever you have a coefficient out in front, we're going to go in the opposite direction. If we have to condense, we're going to take this coefficient 2 and make it an exponent on that x. So that 2 goes away. This 3 coefficient becomes the exponent on y. So what this really says is the ln of x squared minus the ln of y cubed. And then the last thing we can do is we can say we have two logs separated by a minus, so we're going to make those into one log, and we are going to divide because this is a subtraction. So this divides x squared divided by y cubed, and that's the end of that. This is one log. The argument is x squared over y cubed. Two logs become one. Here we have three logs that we want to make into one. So the first thing we're going to do is handle these coefficients. This becomes x to the 1/3 power. This becomes y to the 3rd power. This becomes z to the 4th power. Move them. When we have two logs separated by a plus, they become one log, and you multiply those arguments. So this is the log of x to the 1/3 times y minus the log of z to the 4th. Now when we have two logs separated by a minus, these two logs become one log. So it is the log of x to the 1/3 y divided by z to the 4th. Look, I've made one log out of two. Do not write the word log more than once when you're condensing. So our final answer is log of. Now x to the 1/3, I'm going to rewrite that as the cubed root of x times y all over z to the 4th, because a 1/3 power means the cubed root. So there's your final answer for number 3. Number 4, we have 4 logs. We're going to make them into 1. So the first thing I'm going to do is take that 1/2 out and put it as that exponent. The next thing I'm going to do, I think I'll handle what's in parentheses first. So inside the parentheses, 2 logs separated by a plus become 1 log, and you multiply those arguments, c times d. Now these 2 logs, because there's a plus sign in between, we're going to use the product rule. So these 2 logs become 1 log. We're going to multiply those arguments. A times b to the 1/2 power. And then the last thing we're going to do is when we see 2 logs separated by a minus, they become 1 log. So we're going to condense them down into 1 log. This is the numerator. This is the denominator. So we have AB to the 1/2 in the numerator and CD in the denominator. So that's our final answer. But I'm going to change B to the 1/2 back into the square root of B. So that's the natural log of A times the square root of B all over CD. Next one. What we have is 2 logs subtracted from each other. They become 1 log. Log base 2 of 512 divided by 64. Now, I don't know what 512 over 64 is, but I'll ask my calculator. 512 divided by 64. That's 8. So this becomes the log base 2 of 8. I'm just simplifying what's inside there. Now I can ask myself, 2 to the what power equals 8? Well, I know 2 to the 3rd equals 8, so the answer is 3. The word log comes out of there. 2 to the 3rd is 8. The next thing we have is 3 logs separated by plus signs. So 3 logs, if they're both pluses, they become 1 log. And this is the log of E times E times E. E times E times E. E times E times E is E cubed. And we can always rewrite the natural log as log base E of E cubed. We could say, well, E to the what power is equal to E cubed? Well, E to the third power is equal to E cubed, so that answer is 3. We could have also said log base E of E is 1 plus 1 plus 1 equals 3. That's another, there's several ways to do these problems. There is no rule that we can condense when we have two terms that are subtracted or added, so we're not going to do anything to this. But we have two logs that are subtracted from each other, so the two logs become one log. And this is the numerator, x squared minus 16. Denominator is x minus 4. Well, this can be simplified because this is the difference of two perfect squares, so we have the log base 2 of x plus 4 times x minus 4 on the top and x minus 4 on the bottom. And the x minus 4's go away, and what we're left with is the log base 2 of x plus 4. We've written only one log. And I think that's going to be it. I just want to show you one more thing in the textbook. Maybe take a couple minutes. This is on page 332 of your textbook. Down on question number 36, they want us to expand these, log base 2 of xy, but they're telling us that the log base 2 of x is a and the log base 2 of y is b. So if I were to do this problem, log base 2 of xy, I'm just going to put this down at the bottom of this page here, down at the bottom of my notes. If you have the log base 2 of xy, this is on page 332 of your book, and this is question number 36. The log base 2 of xy, they want you to expand. So expanding, one log becomes 2, log base 2 of x plus log base 2 of y. That's just a simple expansion from a product. But they tell us in the book that the log base 2 of x is just equal to a, and the log base 2 of y is just equal to b. So since the log base 2 of x is a, we just get rid of that whole thing and we call it a. Log base 2 of y is just b, so our answer is a plus b. And there is no word log in front of a plus b. It's just a plus b because they're telling us that that is equal to a and that is equal to b. And then, let's see, I think I'll do number 40, the log base 2 of x divided by y. It's very similar. Log base 2 of x divided by y, that's the quotient rule. One log becomes 2. This is a log base 2 of x minus the log base 2 of y. And they tell us the log base 2 of x is the letter a, and the log base 2 of y is the letter b. So this is just a minus b. And that's the end of that. That is question number 40. And that'll be it for today. We'll practice all these rules tomorrow in class. Hopefully they'll make sense after you get some practice.